Hello, this is video number 35. It's the second last one for the class. So congrats, you're about done with Algebra 2. And this is Chapter 6, Section 7. And this is all about simplifying radicals with an index higher than 2. And so let's just remember what that means. We've been talking about reducing radicals all the way through this whole chapter. So if you saw something like the root of 48, you're going to take and break that down into factors. And then anything that's not prime, just keep right on going. And then we're going to break these down into twos. And then remember that you were pairing things up to get one of them out, right? And you'd multiply anything that came out of the radical, keep anything and multiply if there was more than one. So the answer to this would be 2 radical 3. Well, just as a reminder, the index is the number that the little superscript that you see in here. And if you don't see one, it's an implied 2. So when you reduce a radical, if you no longer have a 2 up there, but let's say you have a 3 up there, what happens and how this is important is the value of the index is the value of how many you have to group together to get one of these out. So in a square root, the index is an implied 2, so you're grouping together 2 of these roots to get one number without a radical. So how does that change if the index changes? Well, we're going to break down the radical the same way, except if you're used to looking at the root of 4 and knowing that that's 2, that can't happen when you do cube roots because now you're looking for something different. So make sure that when you break down a radical that has an index higher than 2, that you go all the way to prime factors all of the time. Okay, that's super important that you do that when you break this guy down. So what we're going to do is we're going to break it down just like we did. 48 is still 16 and 3. 16 still goes to 4 and 4. The 4, though, goes to 2 and 2. This one's gone. The 16's gone. 2 and 2. And this guy's gone. And technically, these would all have little cubes in here, right? I don't really expect you to take the time to put those cubes in there, but I'm just using that as an illustration in this first example. So you need to note the value of the index, and you need to group that many together to get one out. So group that many factors together to get one out of the radical. So here's what I mean by that. In this one, the index is 3, so I need to group 3 of the same number together to get 1 out of the radical. Just like in the last problem, you had to group 2 together to get them out of the radical. Anything left over, if you can't group them into 3s, will get multiplied. Anything that comes out would also get multiplied. So this is going to be 2 cube root of 6. And the big thing here is to make sure you don't forget this in your answer, because if you put 2 square root of 6, it's not right. Your answer should always have the same index as the problem. Okay, so that's just another note. The answer should always have the same index as the problem, unless you completely get rid of the root. Okay, so And here's what I mean by that. If I took the cube root of 125, well, that breaks down into 25 and 5. And the 25 breaks down into a 5 and a 5. And remember, my index is 3, so I need to group 3 together to get one out. And the 25 is gone, and there's nothing left over. So 125 is what's called a perfect cube because it reduces to a whole number, which means 5 times 5 times 5 is 125. So if the radical goes completely away, that's the only way you wouldn't have the same index as in the problem. All right, so let's just practice a couple more of these. This will be a pretty short video. The next one has a different index. We're going to go the fourth root of 324. Okay, and when I did this, I broke 324 into 4 and 81. Well, the 4 is going to go to a 2 and a 2, so the 4 goes away. 81 is going to go to a 9 and a 9. Each of the 9s will go to a pair of 3s. Okay, well, note the index is a 4, so that means I need 4 of something to get one out. Okay, so I have 4 3s here, so that gets me 1 3 to come out. These guys can't come out because there's only 2 of them. So my answer is going to be the 3 that comes out of the radical and then the 4th root of 4. And this 4 is the same as this 4, right? This 4 is coming from these two 2's multiplied together, just so that you're clear on where those came from. Okay, one more example that looks horrifying, but it's really not so bad. Let's take a look at this guy. It's the cube root of 1372, x to the 9th, y to the 3rd, z to the 5th. And the variables are handled the same way as the numbers are. So if you recall when we did square roots, I asked you to break these into multiple radicals. So you'd have the cube root of 1372, then the cube root of x to the 9th, the cube root of y cubed, and the cube root of z to the 5th. All right, so let's deal with these one at a time, and I'll do them all in different colors for you. So the 1372 breaks down into 4 and 343. Well, I remember from when we did perfect cubes and factoring that 343 is actually the cube root of 7. So I know 7 goes in. So that's 49 and 7. That guy's gone. The 4 becomes a 2 and a 2. 4 is gone. The 49 will become a 7 and a 7. And that guy's gone. So here we have the index is 3, so I need 3 of them together. So these 3 will give me a 7. And so what I like to do is separate these completely and then make an answer at the bottom. These guys won't come out. So I'll have 7 cube root of 4. And then when I do my variables, remember, you're going to, for those of you that struggle with these, 1, 2, 3, 4, 5, 6, 7, 8, 9, just write them out, put them in groups of whatever the index is. They're all going to go away. So this becomes x to the 3rd with no radical for the x to the 3rd. Y to the 3rd is going to be the root of y times y times y. They're all going to get grouped together. So 1y is going to come out. And then the z is 5 of them. 1, 2, 3, 4, 5. So I can get 1z out and have a cube root of z squared for these 2 left over. So now I can put whatever is outside the radical. So I have 7x cubed y z, 7x cubed y z. And then under my radical, which is a cube root, I have a 4 and a z squared. And that's it. Okay? I'm fairly confident you guys can go and do all these problems. All right, toodaloo, only one more lecture left.